Hello everyone. Let us discuss the problem where we have to find out the remainder of 6 to the power 83 plus 8 to the power 83 upon 49. So we are dividing this expression by 49 and we want to find out the value of the remainder. So obviously this involves modular arithmetic. I have plenty of videos on my channel explaining this, but I will soon make a very detailed guide about this. This is very helpful for those who want to understand number theory in general, also are appearing for exams like ISI CMI and are in college level and have taken a number theory course. So how do we proceed? So first of all, the first key information here is phi of n. What is this? This is called the Euler's Totient function. Now this is very important. So what does it represent, phi of n? Why and why do we need it? First of all, phi of n gives you the number of integers, positive integers actually, less than n. Okay. So we are going, so phi of n basically gives you the number of integers which is less than n and co-prime to n, which means the number of integers or every integer which is less than n and does not share a common factor with n is basically counted. So phi of n gives you that. So in general, phi of a prime number p to the power some power k is nothing but p to the power k minus p to the power k minus 1. So just remember this. How does it come and how is the evaluation and derivation done? We shall not be talking about that in this video. Now, next comes Euler's theorem, which states that for a integer a greater than 1, we have so if we have an integer a greater than 1, we shall simply have a to the power phi of n. So let me just write it correctly. A to the power phi of n is congruent to 1 mod n. Okay. So this is valid for any natural numbers a and n. So, okay. So now, first of all, how do we proceed and how does this help us to find this? So you can simply write. So now I can start the solution that could be termed as theory. If we take n as 49, we see that phi of 49 is nothing but phi of 7 square, where 7 is a prime, correct? And since 7 is a prime, the answer is going to be 7 square minus 7, which is nothing but 49 minus 7, which is 42. And you can take a as 6 and a as 8 one by one. So two equations come. First one is 6 to the power phi of 49 is congruent to 1 mod 49 according to Euler's theorem. And the second equation that comes is 8 to the power phi of 49 is congruent to 1 mod 49. Okay. Now, what is this? This becomes 6 to the power 42 is congruent to 1 mod 49. And if you square both sides, which is allowed exponentiation, you simply get 6 to the power 84 is congruent to 1 mod 49. Similarly, this one can be reversed, done in the same way as 8 to the power 84 is congruent to 1 mod 49. But that's not what we want, do we? We actually wanted power 83 and not 84. So how do we do that? Well, of course, you cannot divide in modular arithmetic. But sure, what you can do is you can basically multiply by inverses. So if I multiply it by 6 inverse in the realm of mod 49, I would simply get 6 to the power 83. And on the right hand side, I would get 6 inverse. So I'm simply multiplying by 6 inverse, okay? Mod 49. And similarly, here I would get 8 to the power 83 is nothing but 8 inverse mod 49, correct? And if you add them up, you simply get 6 to the power 83 plus 8 to the power 83 is nothing but 6 inverse plus 8 inverse mod 49. Now, how do you find 6 inverse? Now, 6 inverse is simply a number x such that 6x is congruent to 1 mod 49. Do you understand? So we understand that x is such a number. Now we can find such a number because we can see that I've changed the pen here because the previous one was not really working well. So if you see 6 times minus 8 is nothing but minus 48 and minus 48 is nothing but 1 mod 49. Okay. Minus 48 is 1 mod 49. So which would mean that minus 8 is nothing but 6 inverse. Similarly, if you do the reverse one, you can see 8 into minus 6 is minus 48 again, which should again be 1 mod 49. And therefore, minus 6 is the number which is basically 8 inverse, right? And therefore, if I were to conclude the values then 6 to the power 83 plus 8 to the power 83 is nothing but congruent to 6 inverse plus 8 inverse, and 6 inverse is minus 8. 8 inverse is minus 6. So this becomes minus 14, but in mod 49, we can add 49 again to make it positive. So this becomes 49 minus 14, which in turn becomes 35 mod 49. And at the end, we simply write 49. So the remainder is 35. The remainder is 35. So I do hope you enjoyed the video, you enjoyed the contents. Of course, some things were here left unexplained. You may ask about those in comments or request a new topic in the comment section. But I do have a lot of videos which have been explained before. But if you really need a clear guide on modular arithmetic, I would make so. So just let me know, okay? Thank you for watching. If you're new, do subscribe.